Hi, Laura and Vivian. I am responding to the questions that we discussed today in FaceTime. The first one that you asked me about was from the homework. It was lesson 10, problem 15, part D, which is a diagram that looks like this. I'm going to quickly sketch it out. Boop. And then we're told that those guys are the same, and we're told that this is the same. And we're supposed to choose which congruency postulate is applicable here. And you guys had the hunch. So our choices are, let me just write them down. Our choices are side, 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 angle, angle, angle side, or hypotenuse leg. And I think your thinking was that because it's a right triangle, a pair of right triangles, that hypotenuse leg would be the right call. And that was a good hunch because they are right triangles. This one only works for right triangles. But remember, H stands for hypotenuse, and this is the hypotenuse on both of the triangles. And we don't have any information about the hypotenuse. So that's why we have to rule that one out, is because we've got information about one leg that matches and the other leg matches, but we don't have information about the length of the hypotenuse and whether they're the same. So we can't rely on this one. And you guys also were able to rule out side, side, side is the same reason. We know these two match, we know these two match, but we don't know about the third sides. Let's see, what is the right answer on this one? The right answer on this one is side, angle, side. And let's see if we can rule out this one. We're not told anything. We know that these angles must be the same, but we're not told anything about those two angles. We don't know that those are true. We would need to see that. And we don't know anything about these two angles. Okay, so we have to rule out this one because we don't have any information about the angles other than this one and one of the sides. So we have angle and side, but we don't have one of the other angles. Of course, if we had one, we would have all three, right? So side, angle, side is the right one because we've got the side and the angle, and then this is the same. The symbol that we use is usually a circle when we want to show that they're the same, and I'll circle the circle. But those are the three that we use to come up with the congruency postulate of side, angle, side. All right. The next one that you asked me about was from lesson 11, problem 19C, and it's the same type of problem, right? Let me just get the diagram in front of me. C, in this case, the picture looks like this. Pretend it's perfect. It's not. We're told that these guys are the same, and we're told that these are the same. So what else can we deduce from this drawing? And here, let me just make the list again so we know what our four options are. And hypotenuse leg. Okay, so what else can we add to this? We see that we've got one angle and one side. So that rules out this one because we only have one of the sides. And we can rule out this one because it's not a right triangle, so it can't be that. So the real question comes down to, we have one angle and one side, so that means that that could work or that could work. But we need one more piece of information. The question is, can we find one more side or can we find one more angle, right? Because if we find one more angle, then we know the third one, so that's not a problem. So what else can we find? The only thing that I can find in this diagram that we could add would be that these two are vertical angles, so they must be equal. So that gives me one more angle, so that, and I don't have any information about another side, so I rule this one out and I choose this as my answer, and let me double check. Yeah, that's the right answer. This is the right answer for this one, and this is the right answer for this one. Let me know if that makes sense, but you guys have the right strategy. It's all about ruling things out, identifying. I like to do this. I like to underline the pieces that I know in any of the postulates that I haven't immediately ruled out. And then like this, it helped me. Okay, I can see I've got one of each. Now, can I find one more side or can I find one more angle? And when I looked at it, I noticed, oh yeah, these are vertical angles, so they are the same. Vertical angles are always the same. Okay, I love these exercises though because they give you practice in thinking about proofs without having to go through the tedious process of documenting them in that traditional style. I like this mode of thinking. All right, and the third question you had for me is homework lesson 12:21. And there that one is. I'm going to copy it. This one is a tricky little guy. Okay, we know that these negative exponents need to be flipped, right? Reciprocalized. And normally we would say, okay, anything with a negative sign, we'll just send that down here to the basement and we'll send these guys up to the top. The problem is right here. That rule of flipping using our minus signs as trapeze bars and flipping them down to the basement, that only works if we're multiplying or dividing. If we're adding, which we are here, it ruins the simplicity with which we can do this. What that means is that we have to consider these as separate terms and not use this whole thing as one big term. So our next step is to say 1 over x to the third times 1 over y to the first power, I'll put the 1 there, but you don't need it, plus 1 over y to the fifth. That's my new numerator. Do you see how, because of this plus sign, we can't push them all the way down to this denominator? We have to create new denominators. It's all because of that plus sign. Drama, right? And then our denominator, what we can do, now this one could flip up, but because we've got drama going on up here with the plus sign, we're going to be very careful about that, and we're going to take this strategy instead. We're just going to push this to the denominator of the denominator, okay? And you'll see in the next step the way we combine that. So what we did, because of this plus sign, we had to create fractions out of these. We can't flip them all the way down. Then, since we did that up here and it was already a mess, we're just keeping the denominator minding its own business. Now we have a complex fraction, and what we're going to do is we're going to multiply by the reciprocal of the denominator, right? That will we're multiplying. That will cancel down here, but we have to do the same multiplication up here to keep it in balance. Third rule of algebra. Put parentheses around this so we don't confuse it. Now, this whole thing has turned to 1 and it disappears. Yay! And now what we need to do is multiply this against the two parts of this binomial. This I can mush together. That will be fine. And then we will be able to see what we've got. Okay, so we just have 1s all across the top. So I can see that this is going to be x to the fourth plus x to the fourth, right? That's multiplying It's 1 times 1 times x to the 4th, that's x to the 4th, and then plus 1 times x to the 4th, there's the second one. On the bottom, we have x to the 3rd, and then y to the 1st and the 5th. We're using the product rule for exponents by combining these two, so we add them. So that becomes y to the 6th. And then we multiply this one times this one, and this becomes y to the 10th. Again, we add the exponents. Okay, what's next? We can use the quotient rule to simplify this, and we'll have x, right, because it would become 4 minus 3, so that equals 1. So that's x to the 1 on top, y to the 6th on the bottom. That y looks almost like a 4. Plus x to the 4th over y to the 10th. Okay, I'm going to copy this to the top of the next page. X over y to the 6th and x to the 4th over y to the 10th. Okay, let me just check and make sure. Every time I move my book, I run the risk of moving it out of the camera frame, so I always check. All right, so we're getting close. We need to be able to match these denominators so that we can add, right? We've got adding fractions here. Our least common multiple is going to be y to the 10th. So this side is fine. We just need to multiply this by y to the 4th over y to the 4th. Again, it's a product rule situation, so we would add the exponents on these matching bases, and that will give us the y to the 10th we want to match. We have to do it top and bottom. So our new numerator is x y to the 4th over y to the 10th plus x to the 4th over y to the 10th. And for our final bit, we can smush that and we get x y to the 4th. By smush, I mean actually add it. Although we can't combine those terms, but we can show them as a sum, and it's all over y to the 10th, and that is our final answer. Okay, so again, the trick to this problem is recognizing that because of this plus sign, we have to take a different strategy in simplifying these negative exponents. We have to leave these as separate terms. We can't just flip them down. So we have to use this treatment. And then because we're doing that in the top, we just go ahead and leave the denominator as a separate piece. We don't flip up into it. Although here's the thing, you guys, when we handle the complex fraction, we're basically doing the same thing, right? So don't worry about that. Just see it as two separate steps. All right? If you have more questions, let me know. But that is an explanation of those three problems. And I hope it helps you. I'm really glad you asked me about it. Thanks, guys.